Hello everybody, thank you for joining today's presentation. My name is Cristian Butnarasu and I live and work in Bucharest, Romania, where I'm a dental technician since 2014. I am a MINEC Knight class 2020 and a close collaborator for the MegaGen Romanian Digital Laboratory. I'm very honored and grateful to be a part of the third season of the MINEC online education program, Normalizing Digital. Before starting my presentation, I would like to thank Dr. Sam for his particular attention for the dental technicians and his desire to show the technical parts that are involved in a case. Today's presentation is called From Scan to Plan, Same Scan, Different Option. And the main idea behind it is to show how we can use our intraoral scanner for obtaining something different than a crown or a bridge. As I was saying before, thanks to Dr. Sam particular care for the technical stuff, today I'm going to try to show a case from a technical point of view, showing the use of emerging technologies in dentistry and having a full digital approach. In short terms, I'm going to show you step by step how, starting from an intraoral scan, we go through the necessary steps to make a surgical guide for inserting a post-extraction implant with immediate loading. I think this presentation can be considered as a tutorial on how to make a surgical guide and a crown for immediate loading. So if you want to start planning, keep the link of the presentation and then follow the steps that I will be presenting today. The keywords used today will be intraoral scan, CBCT scan, virtual wax-up, virtual planning, computer-aided design for the surgical guide, computer-aided design for the screw-retained crown, the guided surgery, and the immediate loading. For a better understanding, we're going to transform these words and organize them in steps and then explain them one by one. So, the first step when we want to make a surgical guide is to collect the information, and the minimum requirements for a surgical guide are the intraoral scan, the CBCT scan, and the virtual wax-up. The second step is to analyze the data that was collected and start searching, planning, and designing the solution that we found for the patient. And last but not least is the doing or the acting step, where we can finally put in place our planning and design through the guided surgery and the immediate loading. Now that we know all the necessary steps needed for a surgical guide, we can start analyzing the case as it was presented in the laboratory by the doctor. The diagnosis in this case was put by Dr. Mihai Sandulescu, which I want to thank for the amazing photos and the time dedicated for helping me do this presentation. As we can see, the tooth 2-4 had a vertical fracture with previous endodontic treatment and no coronary reconstruction. Also very interesting, but also complicated, the doctor found a supernumerary tooth in total inclusion because of the on the vertical palatal fracture that aspect was of the very root, deep, the tooth needed to be extracted. And in order to try to conserve the bone, Dr. Mihai decided for the immediate placement of the implant. We can easily see that because of the supernumerary tooth, there was very little freedom left for the positioning of the implant. So Dr. Mihai asked for a surgical guide and we started collecting the data. Please note the situation of the patient. He didn't lose a single tooth before, and for sure he wouldn't be happy with the conventional loading protocol. So this was another reason, together with the possibility of supporting the gingival architecture, for doing a surgical guide with immediate loading. Returning to our digital protocol, the first data we can register is the intraoral scan. We need a good optical impression since the quality of the scan reflects the fitting of the surgical guide. The scanner used is a tree shape, but lately we can say all new scanners have the necessary accuracy, especially when we're scanning teeth. Remember that both upper and lower jaw are needed for when we design the crown for the immediate loading, but also for designing the digital wax-up. And since we need to use the scan file for planning in other softwares, we need to make sure that the scan file is in an open STL format, standard tessellation language. Now, just to have an idea, next we fast forward a movie of an intraoral scan file. the patient's scan file, and we will see later on that for a surgical guide, this surface becomes a marker for the superimposition process, which means the matching between the scan file and the CBCT. The second requirement for a surgical guide is the CBCT. The cone beam computed tomography gives us information about the bone structure and dental anatomy. The recommended field of view is 8 by 8, but in this case we choose 5 by 5 because we wanted to show what kind of cases you can do with the smallest field of view. Don't forget to export in a DICOM multi-frame format so you are able to work with this information in other softwares. You are probably wondering when can you choose a 5 by 5 field of view. The answer is when you have natural teeth mesial and distal to the implant site, like we can see in the movie. The reason we need to have natural teeth is because we want to have a nice and clean CBCT free of scattering, so we are able to do the superimposition between the CBCT and the scan file. The last requirement is a virtual or digital wax-up. The digital wax-up is a preview of the final work, and in this case, since we have the tooth to 4 present, we can consider the natural tooth before extraction as a wax-up. But in order to make room for the guide, we need to virtually simulate the extraction. So I took the opportunity and made a new wax-up to show the advantage of having a scan file before the extraction, because this way we can make a wax-up that copies the anatomy of the natural tooth, like we can see in this short movie. Finally, the data collection step is over, and now we can focus our attention to the second step, which is planning. In this stage, we can start merging the data with the use of AutoGate planning software and position our implant from bone and prosthetic point of view. Then, based on this implant position, we can start designing our surgical guide, the screw-retained crown for immediate loading, and the digital model so we can have a full digital protocol, as I mentioned at the beginning of this presentation. In order to use the software, we need to go to the r2gate.com website, hit the join button, and make an account. Nothing too complicated, just fill in a few blanks. Once the account is made, we can download the software from the R2Gate Windows button. Don't forget to check the install requirements to see if your computer is compatible with the software. And yes, the software only runs with Windows, so for those who want to install the software on a Mac, you must have Parallels. After downloading is completed, run the install button, and once R2Gate is installed, then you will find two shortcuts of the R2Gate and R2Ware software and an R2Data folder on your desktop. Before analyzing the bone and placing the implant, we need to run a few operations like CBCT importing, the windowing, and merging between the CBCT and the scan file. Remember that the CBCT of the patient needs to be in a DICOM multi-frame format, and in order to start a project in R2Gate, we need to place these CBCT files together with the scan file in the R2Data folder from our desktop. Then we can double-click the R2Gate shortcut and open the program. To open a CBCT, write down the patient's name in the search window. Then, to open a new project, hit the New Project button and insert a name for your project. Then click the Start R2Gate button. Once the CBCT is opened, we can move on to the windowing procedure. The windowing step is a function of R2Gate that allows us to reconstruct the grayscales to color figures. This way is more easy to see the bone shape and density, and this way we can predict initial stability that is necessary for the immediate loading. The color figures are black for the air, red for the soft tissue and soft bone, blue for the medium bone, and yellow and green for the hard bone. Select Level option first. Then, adjust the green line to the hard bone first as a reference by scrolling the mouse. Next, select Width option and according to the CBCT color values, black for the air, red for the soft bone and soft tissue, adjust the other section by scrolling the mouse and then hit Apply. Next comes the STLization, the conversion of the CBCT into an STL, so we can superimpose with the STL of the intraoral scan file. Make sure that the teeth are placed in the yellow area and select the appropriate color so that the parts that need STLization appear. Import the intraoral scan file from the icon Import Main STL and then 3-point auto match the STL of the CBCT with the STL of the intraoral scan file. R2Gate has two matching modes, auto and precise. For precise matching, you have to select the second step, fine-tuning. Using the arrows from the bottom control 1, 2, 3 that stand for the sectional, frontal and sagittal view, we can move the STL of the model until it matches the CBCT. So this way we can correct errors from the auto matching if necessary. When the matching is completed, we can move on to step number 8 from R2Gate, the implant placement. By clicking on the tooth number, we will obtain a dummy implant that we can move around with the drag and drop function. For selecting an implant, we have to right-click on the mouse and a window will pop up with Select Implant. Then we can choose our manufacturer, the implant type, the diameter, and the desired length. For fine-tuning the implant position, we can use the gaming keyboards W, A, S, D for translation movements, Q and E for tilting the implant. Note the supernumerary tooth in inclusion on the palatal aspect of the tooth and notice how little room was left for the implant placement. For a better understanding of the bone density, we can activate the digital eye from the filter number 5 of the digital eye icon. For prosthetic evaluation, it is possible to import other STL files from the icon Import Supporting List. The antagonist, for example, or the segmented tooth from the CBCT that needed to be extracted. This way it was possible to evaluate the initial stability of the implant and to decide to go for the immediate loading. We can clearly see the red outline of the implant that outcomes the green outline of the tooth that needs to be extracted. It is possible to make measurements by activating the ruler icon. Before moving on to the surgical guide design, we need to export the implant position. And in order to do that, we need to right-click on the mouse, then we can select Abutment Change, R2 Guide, and Regular. This will help you visualize the drilling core of the guide and check that it doesn't interfere with the remaining teeth. Also, we need to orient the window of the guide towards the doctor, because through this window we can have control over the internal hex position of the implant. Finally, we can hit the STL export button and choose a name for our files. Files will be automatically saved in the project file folder. The file with the RWS extension is needed for the stand design in R2ware, while the standard STL file will be used for the design of the crown in Exocad. The standard STL file is nothing else than the intraoral scan with the scan body attached to it. The STL export is the final operation that we need to do in the R2Gate planning software. Now with the exported files, we can move on to the surgical guide design that is done in the R2ware software. Find and open the RWS export file that we saved previously. Then set an insertion view, followed by remove undercut. These steps are necessary to give the guide an insertion path. Proceed with draw boundary to choose the teeth that will support the guide. Connect the yellow dots and cut boundary to remove the rest of the mesh. Hit the preview button to generate the stand and set windows that will help you check the fitting of the guide before starting surgery. There are various shapes for the window set. You can choose the most appropriate, and when you're done, hit the apply button. We can save design by clicking Output Design button. This kind of guide has the contact with the teeth in surface, but it is also possible to design a structure for the guide with contact points only. It is up to the technician or doctor to choose which type is more appropriate for the case. With the design of the stand completed, we can move on to the next step, which is the design of the screw-retained crown. This design of the crown is based on the library of a titanium base. So after milling the crown, we can cement the tie base inside of the PMMA crown. This technique is called hybrid because it allows us to have the benefits of a prefabricated abutment, but also a customized emergency profile that is necessary for supporting the gingival architecture. Next, we will see how we can use the standard STL file generated from R2Gate to design a crown using a digital library. Designing with implant libraries requires the implant module from ExoCAD. Select the screw retained, click Yes for the scan of the pre-op model, select the PMMA material and click OK. Start the design and then load the scan data one by one. First, the upper jaw. Second, we need the scan marker, that is nothing else than the standard STL exported from R2Gate. Third scan is the pre-op, which in our case is the wax-up. And last, we need to import the antagonist. For detecting the implant position, select the library of the implant used in the planning. Next, we can choose, according to the gingival height, different diameters of the tie bases and different cement gaps between the crown and the tie base. Next, we need to superimpose the library with the STL of the scan marker. The superimposition is possible only if we have installed the implant module and the implant library in the ExoCAD program. Through this superimposition, we are now able to start designing our crown on top of the tie base that we will later cement inside of the PMMA crown. With the use of digital libraries, we can make sure that we have perfect margin lines between the crown and the tie base and perfect screw channels. If we have the Model Creator module installed on ExoCAD, then we can move on to designing a virtual model with digital analog based on the same implant detection that we used for designing the crown. The role of the digital model is to check the fitting of the guide. Sometimes removing the undercuts in digital is not enough to assure that we are able to insert the surgical guide, so that is why we need to print the model. Keep in mind that the digital analog is different than the classical analog. It is smaller and has no retention, so it can be inserted in the printed model. The model with the digital analog allows us to insert the crown and adjust occlusion and contact points if needed. Also, it closes the circle, enabling us to obtain a full digital protocol. With the model done, we have finished planning and designing, and we can move on to the third and final step, the doing. In this final step, we will talk first about the guided surgery, starting with the extraction, the positioning of the guide, the drilling and the implant insertion, and then we will talk about the immediate loading. The extraction was more difficult than expected due to the size of the supernumerary tooth. As Dr. Sandulescu explained, only the palatal root of the tooth was extracted, and after, through there was extracted also the supernumerary tooth. After the extraction was completed, it was possible to insert the guide and check the fitting. In case the stent doesn't fit, then we can trim inside the stent until it's seated properly. Regarding the drilling part, we must say that Artugate doesn't use metal sleeves, but instead relies on a special kit with calibrated and stopper-equipped drills for more accuracy and speed. As we can see in the photo, the guide hole and the drill diameter are the same, and both have a stopper, so the drilling is accurate and according to the planning. Artugate kit is a fully guided system that allows also to place the implant through the guide with the implant carrier. For placing the implant according to the planning, there are two mandatory rules. The first rule is to align the upper line of the implant carrier with the upper part of the guide. This way we can control the depth of the implant. The second rule is to align the green part of the implant carrier with the Artugate window. This way we can control the hex position of the implant. By respecting the apicocoronal position and the hex position of the guide, like in the photo, we know that we place the implant according to the virtual planning. So now it is possible to remove the guide and proceed with the immediate loading. The condition for the immediate loading is to have at least 45 Newton value for the peak insertion torque or at least 75 initial stability quotient. The provisional is made from PMMA, so we can still make adjustments if needed. We can remove excess material or add composite for a better shaping of the contour of the emergency profile. After 1 month, the tissue looks perfectly healed and the patient is happy with the results. After 3 months from the surgery, the patient came back and Dr. Sandurescu was able to scan him for the final prosthetics. With this final intraoral scanning, it was possible to make a comparison between the initial planning and the actual result. And I must say we were very surprised by the accuracy of the guide. We finally reached the end of the presentation. I hope it will help all the doctors and technicians who want to start making surgical guides with Artugate. And if you have any questions, don't hesitate to write me. Stay safe everyone, and thank you for watching.